Thank you very much. As I said yesterday, it's really an unbelievable privilege. If there is something that the younger members of the LFCS can learn, I think, today, is to try and keep recording all these documents. Because after 30 years, many of those outstanding things, eventful opportunities get lost. And we lose something because we are indeed a community. There is a line, a tradition. But I didn't lose some of the things. So here you have the green booklet of the postgraduate exam questions. Indeed, there is such a question as Don was saying, but it was in fact quite easy to understand which of the problems was the open problem and the other. So it wasn't just, but in case, by the way, that was solved. Sometimes later then I brought Robin Milner's is computing and experimental science. So. I have many more, and as time will come, I will mention it. Of course, it's a race against time, and so happy 30th anniversary. Also, so this is the most important event in Italy is the 25th of April, and that is you give speech because it's the end of fascism, and this is when I did when I campaigned as mayor, I had this ascoltare poi fare, which means first listen and then act. But okay, so as I said, the myth, when I arrived in Edinburgh, even before, there was really, to me, it looked like coming to a mythical place. Now, let me just mention these three people. Rod Barstow, just take a look at his CV. Just look at this. No, it's not this. It's not. No. Oh, by the way, it will come. Even this will come later. This is not his CV. Sorry, it was the second one. Yeah. Look, just take a look at this. It's really unbelievable. You have in 62 first papers. But then proving properties of programs by structural induction in 1969. Can you imagine? And then a program for solving, no, this is interesting, a program for solving word sum puzzles. This is, I don't think these even exist anymore, word sum puzzles. If you want, we can talk about that. But it's, Rod, now look at this. This, of course, is very famous. Program, the last one, program proving as hand simulation with a little induction. I mean, these are really, I think, milestones in human, in mankind. I think in mankind understanding. So let me get back to what I was saying. Robin Milner was someone who really was like King Midas, whatever he touched. But that was true also of Gordon. Whatever they touched, they had this gift of making it gold. Even like types in ML types, universal types, it looks to me as something which is sort of like a mismatch, especially because it's not really a universal quantifier. But still, Robin Milner made it like an outstanding polymorphism. You know, polymorphism or ML polymorphism is clearly not the right thing because it's not full polymorphism, but still outstanding. And then Gordon Plotkin, I was always struck, we used to go to him with Bob Harper, and he would simply say, the problem would disappear, would dissolve. And I don't know, but I have this letter. I have this letter from, it's called Invitation, yes. This is how I was appointed. Dear Furio, he writes to me. You may remember my discussing with you a possible job in Edinburgh. Look at the date. It's 4th December 1985. This is my appointment letter. I said I would write to let you know. This I should have done many months ago. This he always said. But one thing led away from another. Okay. At any rate, at some point he says the jobs have been approved on the 18th of December 18th, and so he says, well, please consider the opportunity to come. And so that is what happened. I arrived here in February. I gave my talk, and I was somehow accepted. But look at the closing sentence, please. I still regret not finding time to talk with you at Stanford, he said, because we met there, but perhaps we will now find a much greater opportunity. That was false. Absolutely, we never, so that was always, so let's, we never had really the opportunity. People might remember how it was like. So, but let me just mention, just to compare, look at the proof of strong normalization for LF. If some of you have ever considered it, simply we had these dependent types which got in the way, and so it was a headache. I mean, how are we going to take the terms within the types? But then Gordon said, well, just throw them away. And in fact, you cannot really throw them away, but you can just encode them, and there you have a strong normalization proof by just a very, very simple coding trick. But then Gordon had these outstanding, now I mentioned this, universal generators and the omega rule. The reason why I mentioned it, because one of the big founders of lambda calculus, Henk Barendrecht's thesis was precisely on whether the omega rule was derivable in lambda calculus. Now the omega rule says that if m is equal to n, whenever you replace the free variable x with closed terms, then lambda xm is equal to lambda xn. So it's the psi rule, but restricted to closed terms. Now, he had proved in his thesis that under some assumptions, it is indeed a derivable rule. And then came up Gordon, I think this was probably your second paper in lambda calculus, who built two extremely complicated universal generators who actually falsified the hypothesis. And I was always, this is how I really got to know Gordon. I mean, from his work, this was probably the early 80s, 82, 81, 82. 73. Yeah, well, then, yeah. 73. Well, I mean, this is, now, of course, when I go back to the history of functional programming, I always go back to this Vienna Formal Language Description Languages meeting. Also because I could never really parse whether it was formal language description languages or whether it was formal language description languages. But if you look at these proceedings, they are from '64, there you find basically for all the founding fathers of computer science saying something of what they thought was supposed to be the universal meta language. All of them. You have Dan Knuth talking about attribute grammars. You have, I think, Christopher Strachey talking about denotational, some anticipations of denotational semantics. Well, okay. Let's go on to all the, well, you can read, and these are all basic keywords. Now, how I got involved, because I asked Gordon when we met in France, in Sophia Antipolis, on the symposium on data types, I asked him a question. The question is this: are Scott continuous functions adequate for modeling lambda calculus? Of course, we know that in '69, Dana Scott built the first denotational model for lambda calculus, but my question was whether topology or order did enforce upon us some equations which the pure combinatorial nature of lambda calculus didn't. So what I would have liked was to find a model of pure beta theory. And this is still an open problem. And we wrote a paper together with Gordon that was in 2009. And if you consider sentences, then you find that topologies doesn't force you some sentences. Basically, the answer yes, it is. It does. You are biased when you use order theoretic, when you consider conjunctions of inequalities and equalities. Then there are some conjunctions of inequalities and equalities which cannot be modeled by with topology, but anyway. But the conjecture is, of course, no, but it's still an open question, which is a little disturbing, in fact. I remember more than once Gordon showing me attempted proofs, beautiful but unfortunately there was some line that eventually didn't go through. But this was always a lesson. It was always an experience, even looking at how a great mind like his would address such a problem and share it with me. So anyway, I arrived here in February '86. Now, whom am I? I am this. Why did Don ask me to speak? I really don't know. So look, this is a little bit, you can read in 1980. I was originally I was a mathematician, then I went in Pisa, then to Torino, then I was here for 2 or 3 years, a research fellow, then in Udine University, then again visiting, then principal, rector, mayor, and people ask me, mayors, so the only important law is this: mayors are elected by the people in Italy and stay in office for 5 years and can be re-elected at most once. So I have still 2 more years to go. Now, what I had worked before on was non-well-founded set theory. In 1982, I had a paper on an axiom we called X1, which essentially is the anti-foundation axiom. And we had, of course, the bisimulations and co-inductions because it was a maximal fixed point. And I worked on the semantics of intersection types, which is what very much related to what Samson Abramsky probably at the same time did in a much more principled and broad way, but we did it essentially for 4 types. Now, my arrival in Utopia, or if we go back, it's called the Broadband, I think, in Gulliver's Travels, when you go to the place where where giants live, you know. That's how I felt. And so I was staying at the Milners, and the top floor of their apartment, because they were very, very hospitable, up until a point where David Park, who also was staying there in the same top floor, got fed up that I was there, and so he decided to go and look a flat for me to stay. And I thanked him and I moved out of the house. And of course, it was amazing that David Park was there, and he was constantly playing Bach, the Volt-tempered clavier, on a computer, because he was working on a performer enhancer. That was his concern those days. And I don't know if he achieved this, but anyway, I didn't even know what enhance meant when he told me, no, I'm wearing a performance enhancer. I didn't know what it meant, and so I had to look it up in a dictionary. No, really a hard dictionary. It's not like today you do Webster, enhance, and...
steroids,
sorry?
Anabolic steroids.
Now, then I met wonderful people: Don Sanella, Colin Sterling, Stuart Anderson, of course, Bob Harper, and Arnon Avron, who is here. I have, and he used to shout to me, "What is computer science?" Can you say that again, please, Furio? Furio, tell me, what is computer science? Because he was a mathematician and a logician, and so he arrived here and was constantly bothered by this ontological question. And in fact, he was from a philosophy department. He just got his philosophy doctor. So what is? But he didn't ask that. Please tell me what is computer science. He was just to shout to me, like it was my fault that it wasn't clear whether computer science was a science or anybody else's fault. This is. So Ian Mason, Tim Griffin came here with the synthesizer generator, and then Jenny Moji, Tatsuya, Brian Ritchie, Randy Pollack, I don't know if he's here today, also gave a very, George Cleland, and then there were also Hugh Stabler and Morna Finlay, who were the first technical stuff. So my first assignment by Roman Miller, which I really don't know what it meant, was experiment on how you can implement a logic on a machine. That's what he told me. And I don't know, he gave me also a paper. This I still have. It's a paper which has just a coffee stain, because, you know, theoretical computer science, as much as mathematicians are really machines for turning coffee into principles. No, I can't find this. No. It's computing. No, it's the use of machines to assist in rigorous proof. But I can't find here the paper. Well, anyway, I have that, and it's not so interesting. I think it's good comparison to the other paper which I talked about also yesterday on is computing and experimental science, because there is this distinction there of a theory of how, which is a pragmatics, and the theory of what, which is a theory. Of course, the example of types and modules is a clear example where the theory of what, the theory actually provides substance to the theory of how, to pragmatics. But then he also mentions infinite objects as an example where you have, from a theory of how, you build processes, but this leads to taking vicious circles, or infinite objects, non-well-founded objects as objects. No, sorry, so I was staying at the minute, this, okay. No, the LF logical framework, this is what we did. I was very, very proud when I read that you have it also on your website, that we got the Test of Time award for that paper. And this is something that I have to show you using a different technique. I think this is, whose handwriting is this? Gordon. Okay, so this I think is the first presentation of Gordon's idea of a general logic. And then we have, oh, by the way, just whose handwriting is this? Colin, yeah, very good, very good. Yeah, Colin was very, I used to teach the program logic course just after him. Then I have another, then we had this meeting. I think this is, yeah, on whose handwriting is this? Very good. Well, look, because we had this meeting, let me see. I think it's, whose handwriting? Rod. This is LF and Institutions on the 6th of August, 87. Now, you see, I have tried a connection between LF and institutions. I was looking back at this stuff. And still I think this is quite a feasible intellectual enterprise to entertain. It is not yet completely sorted out. But this is exactly what I was saying. I mean, how important it is to keep this. Jane, I think I even have one of your first, is that right? I know it's a different color. This is something that Gordon didn't mention when he said that there were different buildings that produced also, in different locations, that produced also preprints of different colors. So computer science was orange and LFCS was green. Yeah. But let me show you another. You know, I was not good enough in putting them all in PDF. Oh, yeah, this is my reply to Gordon, to Gordon's letter. Dear Professor Gordon, you know, this is the invitation when he invited me. I replied to him, Dear Professor Gordon. So you see, but look, I brought this up because at the time in Torino, you see, you used to type things. And the symbols, like braces, well, you had to write them afterwards, and you have to leave a blank. I mean, that's how things, and it looked very, very normal. I mean, 7th February 1986, in 30 years. Yeah, and you see, I finished the saying, I will send it to you as soon as it is typed, where typing means something different. This is what I wanted to show you. So this is the first workshop on general logic. I think the next types meeting will be in Novi Sad, and probably 2 months from now. And that is an event that has been going on for basically 29 years. And all through funded first by the Esprit projects and then by all the various framework projects of the EU. That was, I think, the basic research was Framework 2, and then now we're at Framework 6. And this was the first one. And you see, it's the 6th floor common room. Gordon Popkin gave gave 2 talks, a welcome speech. He was the leader, really, and also a search space. Towards a search space, here is the original handout where there are some very, very beautiful, and there are more, I have many more. The Martin Leff paper is from that talk, The Logic of Judgments. Ian Mason was representing Hoare's logic, Peter Axel. De Bruyn, yeah, we will get back to that. So I think I have shown you enough of these. Probably you want to see this. Whose handwriting is this? Yeah, that's Don Sanella. Good. So I'm glad that you're getting them all right. This, well, here this is easy. But look at this is also quite interesting because it tells you a lot of the history of LF. It says, you see, these were the first attempt to build a general logic. You know, the LF, the logical framework, was a general logic. So it says, read it. Formulating many sorted first-order logic and type theory in Gordon's general logical framework. So Gordon was very, very kind to us in making us part of that enterprise. And so our names have been tied up. But really, as you see, in those days, we refer to it as Gordon's. Now this, I don't know what this, whose handwriting is this? Rod. Yeah, well, no, enough of this game. Look, no, this is enough of, I can't get it, sorry. Enough of that. Some sentences of this, you know, when I hear those sentences, I really feel like being like an epic. So Martin Leff used to say, what has been done can be done. And put your knowledge into practice. You know what this is? Well, what has been done, what can be done, what has been done can be done is really introduction rules. And put your knowledge into practice is an elimination rule. No, but this is true. This is, I mean, this is I'm talking about philosophy. Now we had other very important sentences. One of them, we were always trying to implement, to show that this general framework was a general meta-language. And sometimes, very, very often, it didn't work. And so we were always struggling and twisting and turning these logics. And of course, you could say, then it's not general enough. But Bob Harper had this very, very, I think, bright way of expressing our failures by saying that LF is normative. So when you actually encode something in LF, then that should be the formalism. Okay, now let me go. Oh, this is, so when we had the toast, so here you can see Arnon, Ian Mason, that's myself. And this is Bob Harper. And we were also doing a lot of cooking. You know, I was being Italian, I was supposed to be a good cook, which the assumption, so I had to learn a little bit. Okay, there are many more. De Bruyn, we invited De Bruyn, who of his in Eindhoven in the late 60s. He had started this Automath project, and they had machine-checked Landau's mathematical analysis book. And when he came here, the only thing he talked about was this Gilbreth principle and quasi-crystals and non-periodic tilings and Mandelbrot set and the Riffle Shuffle problem, which now I will tell you, because some of you might not know it. So if you take a deck of cards, and there are many, many tricks based on this. If you they're all related. You take a deck of cards and you alternate red, black, red, black, red, black, red. Okay? All through the deck. Then you cut it in such a way that, say, on the left you have the bottom card is a red and the top one is a red. And then you do a riffle shuffle. And then, okay, so you do just once. A riffle shuffle, a shuffle, the standard shuffle. And then you start handing out two cards to various people. Everyone will get a black and a red. And you can try it. And there are more standard patterns that, in fact, are preserved under this non-deterministic algorithm, which is the shuffling. And of course, you can prove that there are some invariants, and this is what he was talking about. The one with red and black is quite simple, so I just leave it for you as an exercise. It's not an open problem. If you say, first take spades, hearts, say, what are the others in English? Diamonds and clubs. Even if you have this sort of pattern, then if you cut it it is called a Gilbreth shuffling, so you have to cut it in the right place, and then if you shuffle the two decks, this invariant is preserved. Every 4 cards you get, each set of consecutive four cards has the 4 suits. So for some philosophical issues, of course, what is a proof? Why proofs? And we could go on and on talking about this. I'm still wondering, and I think each of us really would have a personal story to tell. The best answer is that I found. I often ask, say, because I do a little bit of science popularization. So I often ask them, what is the difference between solving a Sudoku problem with an eraser, with a backtracking algorithm, or solving it by pure, say, reasoning? Yeah. What is the difference? Ultimately, you solve the puzzle, solve the grid. So what is the difference between the two? And, okay. I worked especially on the adequacy problem for LF. That is, I'd always try to break the system that Gordon had built, and so that was my activity. And still now, I do think about that problem, and the last paper is this in 2016. And recently I have been working on the Fitch-Pravitz, but this set theory, which was something from the 50s that always fascinated me, but it would take too long to speak about this. So, okay, colleagues, friends, now I also want to mention the first types workshop here on February 87. First, the EU, I mentioned this also yesterday. Reading groups. In the early days, these were the first 2 reading groups. Michael Beeson, Foundations of Constructive Mathematics, or really it was Eugenio Destructive Logic, because he was criticizing it bitterly. So it was, rather than constructive mathematics, it was destructive reasoning by Eugenio. And then this beautiful book by Lambeck and Scott, which I haven't yet fully grasped, but I have been reading it since the 87, but this was also very important. The lab lunch, I remember a very nice lab lunch by Mike Foreman using, I think, was it CCS or some other graphical formalism for formalizing Scottish dance. Do you remember that? You remember that, yeah. Okay, more. No, so the question that I was supposed to speak about is why a computer scientist can turn into a politician. Well, of course, quantitative analysis, data is something. You know, I believed in what you could call epistemocracy rather than technocracy, taking which is very difficult, very, very difficult. But indeed, problem solving. I just want to show you a few pictures. This really, it will take too long, and so I will just move on, if you allow me just 2 minutes more. So I will show you, because So this is my manifesto, me giving a speech in Udine. This snapshots from Udine. Let's see, we have mountains, and it's cold. We have these waterways. This is an area view, other snapshots from the city. This is a first problem that I have solved in my 8 years. So we have lots of cars, and of course we would like to get rid of them, and so it's good to build parking lots underground. But there are ramps. So I built a parking lot which is a ramp. You know, normally ramps are what wastes space. But really, this is like if you go in New York and the Frank Lloyd Wright Guggenheim Museum, You see, it is just the corridor. And the same principle is in this parking lot, you see, the one here. Here. Now this, again, it's an interesting, so I signed the 2020 Covenant of Mayors in 2009. We were supposed to reduce by 20% by European level, reduce by 20% the emissions, CO2 emissions from fossil fuels. So first of all, you have to take a baseline. We took baseline 2006. Udine produced 700,000 tons of CO2 in 2006. And today, and by the year 2020, we should reduce by 20%. But it's very difficult, not because of the administration, because I succeeded in reducing even more as far as our premises, but the lifestyles of citizens are very, very hard to change. And so for the time being, we have reduced only by 9%. But a lot of my policy has been really to do this. And this is an example. We had this building that the issue is retrofitting buildings, because old buildings, if you want to make them energy efficient, it's very difficult, because the best thing would be just to pull them down and build a new one. But of course, this destroys memory. This is what we're talking about. This destroys history, the local history. You can't do this, because otherwise we lose our community sentiments. So you have to retrofit, and that is very, very difficult. Now, this is something that I succeeded. I brought the broadband throughout my city. 95% of my the houses are connected. This is fiber to the cabinet, and this I have achieved here without having to actually put more pipes for the fiber optic, but using existing pipes. So other those for street lighting, or, which I always find fascinating, at some point someone suggested it, and I said, well, we have to do it, and we use the sewage. So this is something which I think it's a good combination of innovation and tradition, because of course it's the most prosaic things, the sewage, and you can use it actually to connect to fiber optic. So you have these little objects that you see. This is the pictures from La Video Ispezione. Okay. This is another issue having to do with demographic shift. In 1936, this was the population pyramid. 1971, this is 2011. This is what I tell you when what it means to have a scientific approach. Our old age index at the moment is 215, meaning that every 100 under 14, we have 215 over 65. This is most of northern Italy. So it's an aging society. So you say, oh, this is a population bomb. Who is going to pay for our pensions? Well, then, if you're a mathematician, you say, well, let's look at the time series of the old age index. I mean, if you are a computer science. And so I asked for the time series, and I noticed that really the old age index has been stable for the past 20. So it's not really to be that excited. But of course, it's good to take care of all the elderly people. And so I have been using what are called health maps, where you plot the distribution of GPs, bus stops over the distribution of elderly people. And this pharmacist is very interesting, because at some point, chemists and pharmacists, at some point we were allowed to set up new pharmacies. And so by using these health maps that I had prepared, I said, okay, I think the best point in order to optimize distance, within 500 steps, having a pharmacy, you have to put it here. And of course, the Association of Pharmacists brought me to court because of this, and we are still fighting it in court, and the pharmacy is not there, but okay. No, I wanted to build a science museum, but then I couldn't, so I just built a toy library. And this is me in my toy library. And now this is another problem that we are addressing, asylum seekers. So these are people from, this is the most recent problem 2 years from now, 2 years in the past 2 years. And you see how difficult it is, and how sometimes we have to settle them in gyms or in parks. and now, but at some point, you see, they're quite digitized. It reminds me, because it strikes me, because when David Park said enhancer, I had to look up enhance in the dictionary. Today, when you speak to them, they actually go to their mobile and say, I tell them grazie, and shukran, yes, okay. So they immediately have a voice translation. So the digital world is helping, in some sense, inclusion. So you see they're quite digitized. But they want to play cricket, and which was very difficult because when I first arrived there, that was more than 1 year ago. Currently, we have over 1,000 such people from Afghanistan. I'm finished. Yeah. I put them up in, because during the Cold War, there were many army barracks and camps in Friuli, in my region, because the Eastern Bloc was on the other side. So Slovenia, they were supposed to attack us, or we were supposed to attack them. Now we have really hundreds of square kilometers of unused brownfield army barracks. And so some of them I have utilized for receive these people, but then they wanted to play cricket. And of course you can't buy a cricket bat in Udine, and so I had to buy it over the internet. So, well, this is more example. Like Pi Day, I could go on and on. I don't really want to use up your time. This is some other last thing. I have this program in Udine which is called ePart, E for e-participation. So citizens normally are essentially concerned with mobility. If you make an analysis of what are citizens interested in, it's mobility. And very often their complaints have to do with the quality of roads, or quality of things that have to do with mobility. So we have this system that it's on the web. You can access it, where you can actually geo-reference some issue, some problem, and this allows it. And this system allows you the citizen to trace how the process is, how his complaint is processed. So green if it has been solved, red if it has not, and then of course he gets a lot of information. This is very good, especially for our administrative managers, technical, because they don't really like to have red flags if it is their fault. Okay, I could go on, and so I think I will stop here, and I really express my deepest gratefulness for having had this opportunity. I think that it's difficult to find a bottom line for all this, but I tried also to show you how, if you take seriously what I had learned here, rigor and quality and method and vision, then you can also apply it to other domains where problem solving is really badly in need, like making and helping and trying to increase the well-being of the citizens, which ultimately is really all that we all would like to ensure and to guarantee. Thank you very much.